All right, today we're going to pull back the curtain on how AI actually understands and creates language. We're going to explore the core concepts that drive everything from your phone's predictive text all the way to powerful tools like ChatGPT. Okay, let's dive in.
You've totally seen this before, right? You start typing good, and your phone just knows. It suggests morning, night, evening. It feels a little bit like magic, doesn't it? But what's really going on under the hood? How does it have any idea what you're about to say?
Well, that little predictive text feature, that's really just the tip of a massive iceberg. It's built on the exact same principles that power these huge, complex systems like Google Translate and ChatGPT. This isn't just about guessing one word. It's about understanding the very fabric of language. And believe me, the stakes here are absolutely massive. Just get this, in 2024, one single AI expert reportedly got a signing bonus of $100 million. I mean, that's more than a lot of top athletes make. It just goes to show you how incredibly valuable this tech has become. Okay, so this brings us to the real heart of the problem. Think about it. The cat sat on the mat. Makes perfect sense. But mat, the, on, sat, cat, the? That's just nonsense, right? The order of the words is everything. So the big question is, how on earth you teach a machine to get that? Let's break it down. Well, the secret, it turns out, lies in understanding a very specific kind of data. A type of data where, just like with our sentences, order is the whole game. To really get why order is so crucial, let's look at two different examples. First, picture a spreadsheet of student records. If you shuffle the rows, who cares, right? You can still analyze each student's data just fine. But now, think about daily stock prices. If you shuffle those, the data becomes completely useless. You've just scrambled the timeline, totally erasing the story the data was trying to tell you. And that brings us to our very first key term, sequence data. It's basically any collection of information where if you change the order, you destroy the meaning. Simple as that. And you know what? This kind of data is literally everywhere. We see it in stock prices, in weather forecasts, the very words I'm saying right now, and even in the code of life itself, DNA. In all of these, the sequence is what tells the story.
So if we've got this special kind of data, it makes sense that we need special tools to work with it, right? And that's where sequence models come into play.
To get a handle on how these models work, let's start with a classic puzzle you might remember from math class, the Fibonacci sequence. You know the one, 0, 1, 1, 2, 3, 5, 8. Each number is built from the ones that came before it. It's a perfect, simple way to see how a model can learn from the past.
So looking at this sequence, how would you actually teach a machine to predict what comes after 8? The machine needs a clear rule, something it can follow every single time. What do you think that rule is?
The rule is actually beautiful in its simplicity. The next number is just the sum of the two numbers that came right before it. Or, if you want to get mathematical about it, xn equals xn minus 1 plus xn minus 2. The key thing here is that the present is defined entirely by its immediate past.
Let's walk through a quick example. To figure out the number after 8, our model looks back 2 steps. It grabs the last two numbers, 5 and 8. It then applies the rule, add them together, and boom, it correctly predicts the next number is 13. It's simple, it's logical, and it works every time.
And this idea brings us to our next big concept, the autoregressive model. It's just a fancy name for a sequence model that predicts the next step by looking at a fixed number of previous steps and using some kind of mathematical rule. Our Fibonacci example? That's a perfect, super simple version of this really powerful idea. Okay, but what if we made things even simpler? Enter the Markov model. This is a type of model with a really, really short memory. It predicts the next thing based only on the single most recent step. Imagine a super simple weather model that predicts tomorrow's weather just based on today's weather, and it completely ignores everything that happened last week. That's kind of like a Markov model.
So you can kind of think of these models like a set of Russian dolls or a hierarchy. Sequence models is the big general category. Inside that, you have autoregressive models, which look back a few steps. And then, as the most specific, tiny doll inside, you have Markov models, which only look back one single step. The trade-off is pretty clear. A Markov model is fast and simple, but it doesn't have much context. For something as complex as language, you're going to need a model with a much better memory. All right, so we've got the theory down. But how does an AI actually start to chew on a sentence? What's the very first thing it does? That very first step is a process called tokenization. It's all about breaking down a chunk of text into smaller, more manageable pieces that we call tokens.
Think about it. An AI can't just read an entire book at once. It has to start with these little building blocks. And a token can be anything: a whole word, part of a word, or even just a single letter.
And there are actually a few different ways to do this. You can split text into whole sentences, or more commonly, you can split it into individual words. Then there's subword tokenization, which is really clever. It can handle new or rare words by breaking them into smaller parts, like splitting tokenization into token and ization. And you can even go all the way down to individual characters. Each level has its own strengths and weaknesses, depending on what you're trying to do.
Okay, we've covered a lot: sequence data, different kinds of models, and tokenization. So why does all this foundational stuff matter so much? Let's tie it all together.
So let's wrap up with the big takeaways. First and foremost, for language, order is everything. Second, an AI model's power comes from its memory, how far back it can look to understand context. That memory is what lets an AI figure out that in a sentence like, "the cat sat on the mat" and "it drank milk," the word "it" is talking about the cat, not the mat. That's huge. And remember, it all starts with those building blocks, the tokens. These core ideas are the engine behind the AI tools you're probably using every single day.
So, we've just walked through the absolute fundamental building blocks of modern language AI. And these aren't just abstract ideas. They are literally how these systems are built. So the question I want to leave you with is this: now that these models are getting so good at understanding the logic of sequences, what are they going to build next?